first I want to say to Amy, just quickly, because I don't want to eat into too much of our time here, regarding sifting soil, if you're using the dry method, start with your biggest screen. Well, maybe even start with your hands. Pull any big rocks or clumps of organic matter that are easy out. Then start with your biggest screen you have. And I'm not going to assume that everybody has a bunch of screens. So, you know, some of them might be hand picking, but if you happen to be a gardener and have screens, I usually start with 1/2 inch and then maybe, depending upon what's in the soil, go to 1/4 and then go down a really fine kind of fly or window screen, which I then have to rub through to get the stuff through. And it doesn't take that long, or shake through on the screen to get enough to get, you know, close to a gallon of soil. If you have under that, that's okay. I just want you to have enough to play with. So if you need more than that, let me know and I can write something up to, yeah, okay. Okay, great. Okay, so now I'm going to move over into screen sharing. You will not be looking at me anymore, but you will looking at some other things as we get started to do this presentation. Oh, why are we on that? We're supposed to be starting here. And let me just get the chat window up here so I can see if something comes through that you need to know in the moment. Great, okay. So one other little tidbit, now that we're all on computers and we can take screenshots and stuff, I do wanna say that I have some images in here that I've been given specific usage by the person who took them, and I'm not allowed to share them. So if you would respectfully, if there is something you like and you wanted to know if you could use or have, maybe just shoot me an email. If it's mine, I'm happy to share it, but not all the images are mine. So I thank you ahead of time for respecting the people and their copyrights, etc. Okay, so I want to get into this talk about natural building. But before I start, I want to read you guys a quote. And here it is. Architecture has a responsibility to minimize pollution and ecological damage, responsibility to minimize adverse biological effects on its occupants, and to be sensitive to and act harmoniously with the surroundings. Responsibilities not only to the visual and aesthetic sphere through outer senses, but also to the intangible but perceptible spirit of place. And I wanted to share that because I have a lot of resonance with that. Architecture and buildings, we meet that in so many different ways. So what I am hoping to do today in this presentation is, here we are, zone 1, where we have the built environment in terms of the permaculture model, the home. And so what I want to do is introduce you to some of the various styles of natural building, you know, with the hope of inspiring you and allowing you to see what's possible if you haven't had exposure to this. But I also want you to understand the role of natural building in the global built environment as it really and specifically currently relates to climate change. And of course, the well-being of humans, which I mentioned in that quote. So, moving on to the next slide. Regarding climate change, as you know, it's the destabilization of climate cycles, largely due to the increased level of our atmospheric carbon dioxide, chiefly produced by the use of fossil fuels. So, you know, how does this relate to the built environment? And I want to take a look at where we've kind of been in the natural building scheme of things, and then where we are now in the conversation in this natural building movement. The building industry consumes a lot of our planetary resources, and you're going to see different numbers on this. This is just one slide that has some numbers that are, but you'll see variations on this. But, you know, roughly 40% of the energy and 40% of the world resource extraction is for buildings. So it has quite an impact at a large worldwide scale. Here is a life cycle. And when we go from number 1 here all the way up to number 5, we're talking about the cradle to gate portion of this cycle. And this is really the initial phase of the building. And it's where we extract the materials and a building comes into its existence. And the natural building community for quite some time has had a large focus on embodied energy over the years. And so that's the amount of energy it takes to extract the raw materials. And as you see in this life cycle, and then create the product, transport it, you know, the manufacturing and the installation is all in that sort of ecological accounting. And then, of course, when you're getting into number 6 here in the green, we're talking about the operating energy costs over the lifetime of a building. Then we've got in the blue, number 7, the end of life management, what happens in the grave. And so you can see on the right hand in the blue, there's the most preferred and the least preferred in terms of how we want to be working with these materials over their lifespan. So that's been a big part of the natural building conversation. And now we're looking a lot at carbon, and I'm gonna talk about that, and particularly sequestering carbon as we move through this presentation. But so this is sort of like, okay, we're here now. And of course, this life cycle is still applicable to the present time. Somebody might be laughing, I can't hear you. Normally it's fun in person because there's like gasps and laughs on this slide. And so what is important about this slide is that there's roughly 1.5 million new homes built in the US per year. And that's a lot. So we're like pulling trees out of the ground, processing them and popping them out the other end as homes. And that's a lot of them as they pile up. To give you a little bit of context over time, here we're looking at a mansion model, kind of fancy house that you might see somewhere in the United States today. But 50 years ago, the average home was only 2,000 square feet, unlike the one we're looking at here, and it had 4 occupants. And now our, what we would call single family homes are twice the size with half of the occupants. So we're consuming a lot of resources and kind of rattling around in our homes with half the occupants. So it's important to note when you think about the big picture and what is happening in the built environment over time. In 2013, the average American home was using 16,380 board feet of lumber. And just so you know, a board foot is 1 inch of thickness by 12 wide and 12 long. So the amount of wood in a tree is referred to as board footage. So here you can see a very typical use of wood going up, probably creating some sort of condos, which is great because this is high density housing, so it reduces urban sprawl. But there's a lot of wood that goes into it, and wood is great, and I think it's a great material to use. However, it's just important to contextually understand what's happening to our forests, because one of those single family homes I'm talking about, not the mansion model, the smaller ones, takes about 44 trees from our forests. That's like an acre. And so that's quite a demand if you think times that by the 1.5 million or whatever it is now houses that are built per year. And then the top of this, we've got the pulp and paper industry. We've got remodels. We've got the wood that's needed for furniture, paper, and the like. And this is all added on top of what we're using for home building. So the point being is that there's a lot of pressure on our forests, and you know, how fast they grow in relation to what we're consuming is a problem. And this is one of the other problems, as you know, I'm sure I'm preaching the choir here. This kind of method of clear cut creates a lot of problems in the environment in terms of soil stabilization, species, habitat, water, you name it. You guys, you know about this stuff, so I won't spend much time talking about this. And Oh, by the way, a couple other stats I didn't mention about the wood use. It doesn't include, the calculation doesn't include the 6 decks built per second. Can you get that? Like there's 6 decks built now and 6 more now. 6 more. That's a lot of decks going up. And it doesn't include the 100 million trees that are turned into 20 billion mail order catalogs per year. So that's that's the other sad thing. You've got these clear cuts happening, and a lot of these trees are turned into catalogs. And you know, I don't know about you, but if you're getting in the mail, or you're reading them, or they're going straight in the recycling bin. So as I said, wood's an excellent building material, but our methods for forest management and our harvesting contribute to a larger problem. And, you know, it is a big problem when we're looking globally at how much of our old growth forest has been cut and how we actually manage our forests. After the wood comes out of here, it typically gets loaded on a truck. So this is one of the many parts of transport in that life cycle, and there isn't just one. And it goes to some destination. Maybe it doesn't get there in one go, and it ends up in a holding station here before maybe another company comes and picks it up. You've probably seen these kind of things driving down the highway on a road trip. And, you know, that wood needs to be preserved. So there's sprinklers usually going over it. So there isn't problems with the wood drying out, and you don't want it to check or crack or twist. You want it to be in the best usable condition, because that's all profit, right? And, you know, of course, even if you don't care about profit, you don't want those precious trees going to waste, for sure. So that's a little bit about the wood part in our sort of stick frame construction model, which is one of the primary models here in the United States and North America. But we also are mining for different things for the house. You know, we have glass windows, we have copper wiring, we have other different metals for different uses. And so you can kind of think that for each single family dwelling, there's a hole gouged in the earth roughly to the size of that single family house to provide the other materials that are necessary for that sheetrock. You can think about, like, that's gypsum, which is it's a mineral stone that is ground and fired and turned into a plaster board for our houses. So, you know, those kinds of things come from places like this. I believe this mine is in Nevada. Just a little moment on concrete here. You can see my sign here. It's the second most poured substance on the earth after water. So concrete is an amazing material, but in my personal opinion, in terms of what is happening to the planet, it is overused. The more we have dense, heavy materials like concrete, you know, create a parking lot, we heat up our planet even more because it's gonna bank heat. So there's that. There's a disposal problem, especially we're putting steel in it, so it makes it very hard to reuse. It turns into something different, even though it's made from natural materials like lime and clay and aggregates. It turns into something, it chemically changes, so it's not going to biodegrade, as you know. And it also contributes to a large portion of our greenhouse gases. Some stats say something like 8%. Again, you'll find different figures on this. So, you know, the natural building community really likes to think about, okay, we're going to need it, especially in code approved buildings that we're doing, but how can we design and use it judiciously where it is the most important for it to be used, and reduce the amount of concrete that we're using, and maybe look to other alternatives. And now I will say that we're at a really great time where there's a lot of different, you know, there's sort of like green concretes coming out, and people really are exploring that technology. So that's great. But, you know, this is something that you will show up in sort of your natural buildings, but is not one of the most natural parts, and there's some problems with it. So that's just the little blurb on concrete for everybody. And now, in regard to natural building, which I want to talk about more, obviously, there's some little points to make about what, you know, like what is natural building? It's not green building. Green building is different. Green building is really much more relying on energy efficiency, systems that are efficient, materials that are recycled. And natural building is kind of like a step back from that. So here, you know, I've made a list utilizing appropriate materials that have co-evolved in your bioregion. So appropriate materials, I would underline that part. Resource your materials locally, which relates to the first one. Minimally processed materials when possible. A lot of our buildings, we might be using posts where they're in the round and they're not milled. That reduces the amount of energy in terms of the ecological accounting of that. There's some pros and cons to every one of these things, FYI. Next one, build small, tall, and anti-sprawl as the jingle goes. And so localize the built environment to preserve the natural environment. Offer low-tech options to empower all people. That's one of the things I've loved about working on natural building job sites. It isn't just left to the sort of, you know, big burly men. Lots of people can get involved, children, elderly, that kind of thing. And it's really nice because it feels so much more like a community project. And we've gotten away from that in our sort of modern day society. The use of natural materials to foster health for the homeowners, the builders, and the ecosystem. Huge important. Modern building materials can be very toxic. There's a lot of off-gassing that goes on in our buildings, and therefore there's something now called sick building syndrome, where human beings are chemically sensitive or in reaction to what is in their home or what their home is made of. So natural buildings and natural materials are a way to combat that. Design for durability and flexibility for the lifetime of the building. So think about, maybe you build in phases. How do you add on? How do you make sure that you do your research and do a good job so your building lasts a long time? That's the durability part. Choose energy efficient location for natural heating and cooling cycles like passive solar. I'm kind of assuming maybe somebody can type in the chat window, have you done the passive solar talk yet? Usually that's happened by the time I come on, but so making use of the sun or shading, depending upon where you live and what you need. Using recycled materials, again, tapping into the waste stream and diverting things, which will also reduce the cost of what you're putting into your building, and a duty to minimize waste. Anybody, you want to tell me whether you've done your passive solar talk yet? Okay.
Yes, we did.
Great, thank you. That's awesome. Okay, because I want to be fluid with my talk here, not go over things you've already been doing. Okay, so excellent. So let's take a look at natural building. I want to start with cob for a couple of reasons. Interesting, like 70% of all the trees cut are used in construction. Yet 50% of the world's population are actually living in homes made of earth. So that's one of the reasons why I want to talk about some of these worldwide earth building traditions first. Also because it's where I started in my training in the 90s. I took a cob workshop and fell in love with this earth building technology. It was kind of mesmerizing, especially coming from Vancouver, BC, where you're used to the rain. And it was mind boggling to think like, wait, you can build walls from earth and it's just not going to dissolve. And that this tradition comes from that part of the world where, you know, Devon, England, they have a lot of rain. It whips sideways at times of the year. So this is what you're looking at in this old historical cob building. And the white walls are plastered with lime plaster, which is essentially calcium carbonate. That could be seashells ground up. You know, limestone is the same thing. And it gets mixed with an aggregate and plastered over this probably 2-foot thick earth wall, right? And that lime plaster protects it. And it's amazing because if you went to Devon, England, you would probably still see date plates on buildings from the 17th century that are still inhabited and in use. So when I talk about design for durability, I mean, that is a great example. Even though these buildings are made of earth, they've stuck around for centuries. So if you know what you're doing, you do it right, you can have a very durable, long life to a building. Before we move to the next slide, I do want to say also the tradition with the cob buildings is that they would have a thatch roof, and that's what you're looking at here. So this is typically made from a water reed called Phragmites, and they're long strands of these reed that are piled up and create these roofs, which are amazing and beautiful and can actually last up to 75 years, depending how well they've been thatched. So they last longer than some of our modern like composite shingles do. And not only are they shedding water and protecting the building, they are also doing double duty of being the insulation, because they're very thick when you stack this up. So you've got a couple feet of insulation in your roof right away built into this system. This is the low tech part that I referred to, where you can invite all sorts of people onto your job site. So this is from a workshop. I think this was at the Occidental Arts and Ecology Center years ago. And here we are making cob with the very low tech hand and foot method on a tarp. And so, you know, I was talking about the materials in the soil talk that I did last week, and I was talking about how you can mix this clay soil together and you could add sand to it and then use some water to make it malleable and easy to work with, and then add long straw, which was kind of, you know, I mentioned it was kind of like being the rebar in the mix. And you can create this really strong mix when you get the balance of those things right. And then you can create a wall system from it. And you know, that's one way to do it, the low tech method, but certainly you can mechanize and do this in a larger scale. And this is what this slide is depicting. This is James Stark from the Regenerative Design Institute. We did a workshop there. And what you can do here is you work with your machinery and spend a couple of hours in the morning making a huge pile of cob. You can turn off the machinery and then utilize that stuff for the rest of your building day in the silence and listening to the birds and working with your material. There's, you know, there's some tricks to getting a really good mix when you're mechanizing at this volume, but it can be done. So scaling up is possible. Traditionally, they would have used animals to tread the mix for them, you know, back in the day, so to speak. Here is a cob wall going up. I don't know where this is, but there's a lot of fancy cob luminaries here. Michael Smith on the right, on the left, Patrick Hennebury, and a man named Dana Cobb, no joke, in the middle. And what is important for you to see about this slide is what it looks like before the exteriors. Plaster, you can see they're doing a very nice job of stacking that mud up. You know, certainly you use some tools to make sure it's going straight up and down. Your wall's not tilting, so they're using levels. And then what's really interesting is you can just add your windows as you go. There's some tricks for how they get held into the cob. There's actually a wooden block in there that you can't see that the window frame is screwed into, so it's not just going to slip out of that wall at any time. But it's pretty low tech, and you're creating this really strong system that is essentially a monolith except for where you create openings. So less openings, the better. It's going to be stronger. Yes, we need doors and windows, but you know, depending upon whether you're in a seismic zone or not, you might alter your design to create a specific sort of strength that you're looking for. So that guy on the left in that last photo, he's a cob builder from British Columbia, and this is one of his buildings on Main Island. And you know, that's the British Columbia rainforest up there. So what he's done to protect his earth walls is created these really big overhangs. And there's a little saying that goes with cob building. If you put a good pair of boots and a good hat and a nice jacket on it, your cob building can last forever. And what we're talking about here is getting an adequate foundation so the earth wall system is not going to be damaged by any kind of water over time. I guess I should have said a breathable coat like Gore-Tex. And then the hat piece is your roof. And in this case, you can see those eaves act like big wide brims, so it protects the walls. And then the breathable coat part is the kind of plaster you're using on the outside. You need a breathable coat, just like you want a Gore-Tex coat, you know, when you're walking around in the rain, because you don't want moisture to get trapped inside your wall system, because that will degrade your wall. And eventually, if enough moisture built up, you would lose your wall system. So it's really important to understand what kind of finishes, also known as renders, that you would put on the outside of these buildings. This one just has an earth plaster, and he can get away with that because of these giant overhangs, so it doesn't get messed up by water over time. You can see he has this nice root ball on the left, which is one of the shoulder beams of this cottage, and he left the roots on, something that a builder, Sunray Kelly, made kind of famous, and Petra Canterbury has been playing with that here in this spectacular building, which I think might be on Airbnb. You might be able to rent this. This is a building kind of just outside Nevada City in California. And the reason I wanted to show you this building is because when I was apprenticing in the 90s, another guy named Rob Polachek was apprenticing, and he left the apprenticeship and went home up to the Nevada City area and built this single family dwelling that was 3,000 something square feet. And I was kind of like, oh my God, that's a huge place. Didn't he understand the small, tall, and anti-sprawl thing? And he did. But what he wanted to do was he wanted to create a model, because let's face it, people want big houses. They're gonna, you know, or they have large family. They have to house people. So how can you create a larger square foot house without the sort of ecological impacts that most of our buildings are creating in terms of material use? Again, all the ecological accounting that goes in from the moment of extraction to transport to the protection of the materials to the construction, et cetera, et cetera, et cetera. And so what he did here was he built a house. The stones came from the local quarry. And by the way, this is all code approved in his area. His walls are something like 16 inches thick with cob. He used a biodiesel tractor to mix all the cob. He had a crew of 6 people. It took them 3 weeks to put the walls up. He was very lucky enough to have access to forest on nearby land where they let him fell the trees and bring them over to his property. He had an Alaskan mill brought on site, which is essentially a portable mill where he could mill up a lot of that wood. You can see, looking at these posts, some of it's still, pardon me, left in the round. And so, and then he used anodized metal roofing, which is recyclable, but also he can do water catchment from. There's a portion of the building that has straw bales in it that came from the valley. So all of these things that I'm listing, the materials were extremely local when you think about how we build. They came from within miles to within a couple of 100 miles. We lose that sort of local provenance to the materials when we're getting into, you know, the wiring and some of the plumbing and the doors and windows and that kind of thing. They might have been purchased locally, but they might have been made somewhere else, of course. But in terms of looking at the ecological accounting on this building, it's way lower than probably a conventional house, maybe quarter its size. So it was a really great example of a way to build that has a focus on staying very local, working within your bioregion, doing things that make sense for the function and form and health of, you know, the planet, its occupants, etc. This is taking you inside that building. So that Alaskan mill milled up all the wood to be used on the ceiling. The other stuff were kept in the rounds, as you can see in those big posts and beams with those knee braces on the left. All the finishes that you see are earth finishes. They're all natural. The paints are naturally made. And you cannot see the floor in this slide, but it's a poured adobe floor. So it's an earth floor as well. You might be able to notice the bench on the right near the kitchen table, that's built in, as is some of the artwork high above, like the sun. So lots of kind of stacking functions here in terms of material use and what you're getting out of one material. So, you know, when we're talking about soils the other day, you really, you know, might seem like kind of a simple and maybe for some not very interesting, but when you look at a house like this, the understanding of the material you're working with to create all these different uses from it is really, really important. And here is a more modern European cob house that was built not too long ago. There you can see a newer thatch roof. You can look at the edge profile to see how thick it can be. And this is most likely lime plaster on the outside, again, because like I said, we need something that vapor can pass through. Lime is great, earth is great. Cement stucco, not great unless there's a bunch of lime in it to make it more breathable, as we say in the trade, to allow vapor to pass through it. I want to just give you a little sneak peek into some of the sculptural forms that are showing up in Europe with this modern adaptation of mixing mud and being able to sculpt it. I mean, cob is amazing. If you're an artist, you just, you can't beat it because you can mold it into practically any shape you want. And so, you know, there's some tricks to the trade, of course, but you can get these incredible forms. Again, this is probably lime plaster, the white plaster covering up the brown mud underneath, and or it is possibly gypsum plaster, the same thing that makes our sheetrock can be a plastic plaster as well. I don't mean plastic literally, I mean like movable and spreadable when I say that word. It's all natural. So let's talk about or take a look at some other earth building techniques. And this is adobe. I'm wondering if any of you have had the privilege of going to this place. This is Taos Pueblo in northern New Mexico. I'm sorry, I don't know who the architects were for those modern cob references. If I can find it, I'll shoot an email. So yes, it should be on your list of things to do. It's really incredible. Of course, it's closed right now for COVID, this place. This is in northern New Mexico in Taos. This is at 7,000 feet. That's Taos Mountain behind it. And they say that this is the oldest continuously inhabited pueblo on Turtle Island. So this goes back farther than anybody's records. It's all made from mud brick and it is plastered with mud. They don't have the large overhangs and things I was talking about. They have this flat roof style, but this is high desert. So they're not dealing with the kind of weather we're getting here on the West Coast, or if you're somewhere else in the country, the East Coast or the North, what have you. So again, desert country, lots of sun days. So they can do things we can't do here in parts of Northern California. This is a vernacular style of architecture, and what I mean by that, it comes from the people, the place, and the culture. So this sort of stacked boxes, when you look at it, looks very much like the mountain behind it. It looks like it grows out of the place. Because it's desert, they don't have a lot of timber, so they had to figure out what did they have a lot of that they could build with. Again, their bioregion offered earth, and they made the best use of it. So there's lots that could be said about this pueblo, but we don't have time for all of it. So I'm gonna have to move on, but I will answer this question. So cob versus adobe. So cob can be a monolith in that you're not creating distinct blocks that you're working with. So when we're doing adobe, and this is from another part of the world, you're making these sun-dried bricks. And then you're mortaring them together. And then you stack these bricks up And traditionally it would just be with a mud mortar. Certainly now they're stabilizing these bricks with asphalt emulsion and doing all sorts of other tricks that are not natural. But here's an unplastered building, and you're stacking all these bricks up and you're creating a structure. And it's great, you know, like all the missions in California, you know, were built of adobe bricks. There's lots of evidence of this as a tradition in the United States and many other parts of the world. However, in a seismic scenario, this could be problematic because when you have waves moving horizontally through the earth, those bricks are going to start to want to move off of each other and possibly result in wall collapse. Also dusting, which is how some people can perish in an earthquake in these buildings by asphyxiation, not getting out of the building in time, like in the Guatemala earthquake years and years ago. So that is one reason maybe you would choose to do a cob building over an adobe, possibly because you're in a seismic area. Now, having said that, there isn't codes for cob construction in the legal building code, so there isn't a structure to say yes, you should do. You're allowed to do cob. Now, it's not illegal, but you would need an architect and/or an engineer to sign off on that for you. But that might be one of the reasons. The other reason is maybe you can't build very fast, but you know, like maybe you can just build a bunch of bricks, let them dry, and then later on build a bunch of bricks, and you could stockpile enough so that then when you're ready to build, you may be able to stack all that up and get your building done ahead of time. Cob is different. You're putting it up wet and you're letting it dry in place. So yeah, there's lots of different sort of pros and cons that you might have with both of those. The big wooden beams in the adobe buildings like the Pueblo, what's the role in them? Well, the wooden beams are, as I said, they don't have a lot of wood, but where they are using them, and you can see the big wooden beams on the left in this slide, they're creating a roof structure or a second floor or something. So, and traditionally those, like right now, you would have these beams that essentially act like our rafters, but they keep them in the round. They're called vigas. And then they have little ones that go across the ways. I wish I had a picture. I don't think I do. And they're called latillas, and that creates your ceiling. Traditionally, they would then stack mud and animal hair, and they would just build up all these layers, so water wouldn't get through. Of course, now we have modern building materials, and we have these polymers they can paint on their flat roofs and protect it from water getting in. But that is where they use the wood: doors, windows, these things called lintels, right? It's called a lintel, not a lentil, a lintel over the window that spreads the load. And then, of course, these vigas sticking out here, which create the roof structure. So some of them being exposed, some not. Then again, traditionally on adobe, dating back to what, you know, this as a traditional, not talking about the modern applications, they just put a mud plaster on the outside. And that mud plaster would be repaired every year. It was part of the tradition of the culture. You would come out after the rains hit and start to erode it, and you know, everybody would come out and help out and replaster those buildings. Here's another set of adobes. This is in Tucson, and this is the barrio in Tucson. So some of these are very old structures, these little adobes, and a lot of them had gone into disrepair because people started putting cement stucco on the outside of them. And then over time, what was happening, I mean, it is a desert, but they get monsoons in the summer. So certainly moisture gets in. And of course, just inhabiting a building creates a lot of moisture with cooking and showering and breathing, etc. And that gets into your wall system. And if it can't get out, you start having wall failure, as I said, and then the plaster starts delaminating, all sorts of trouble. This contractor knew how to resolve that and stripped all these buildings, redid them, put on the proper line plaster, and I happened to be in town and got to take a look at these and take a picture because they were sort of being revived in the old tradition in the proper way in a more sort of modern context though, and being rented out again or sold. And he did a really good job. So you really want to understand how these buildings work so you can build them and clad them properly. Anybody know this building? This is a good example because this building withstood the 1906 earthquake in San Francisco. So this is an adobe building as well. Built by, well, technically it was built by the Ohlone Indians who were hired to build it. So that's really who should get the credit for this building. The foundation goes deeply into the ground. Some of these walls are like 4 or more feet thick. You can see how it gets wider at the bottom, which lowers the center of gravity. Imagine if we were in a room together right now and I stood with my feet together and you tried to push me over. And then imagine if I stood with my feet wide apart and you tried to push me over. Like that's a good illustration of the center of gravity. So the more splayed and wide at the bottom, the stronger it's gonna be. So there was all these things that were employed in terms of building techniques that created this really strong building. So when all these buildings went down in the 1906 earthquake, and certainly the fires that happened after that, this building has withstood, pardon me, the test of time. It was built in, when was it built? 1890 something. So it's been around quite a while. I'm kind of forgetting some of my litany here. So this is something you can go see, the Dolores Mission in San Francisco. You can go check it out. Yes, Margot knows it. Yeah, all right. Here is another earth building technique. This was a building I got to go work on in Phoenix after it was construction, but I wanted to show it to you because this is another interesting way to build, and this is called rammed earth. And what happens in this is you're taking an earth mixture, but you're making forms. And I don't have pictures of the construction, but you're putting layers of soil between forms. And of course, in this modern context, they add a bit of cement to make it harden more and put some steel in there to rigidify it, etc. But you're then still getting this really beautiful strata of earth, which is, you know, still the higher percentage of this is earth. So in terms of like what happens of buildings 100 years later, this is much more likely to biodegrade and go into the soil than, you know, some other modern buildings. And then we've got this wood cladding on this other portion of it. This was a beautiful building to be working on. It's set really nice in the desert habitat. It's all on run off grid on solar panels, which I never saw. They're somehow lowered onto that roof. You couldn't see them. So that was a really incredible design element. And this isn't the only other earth building technique. There are more, but we only have so much time. I could talk to you for hours and hours and hours and hours. I'm trying to cram so much in here into one night already. Taking you inside, again, no plaster, you just see, they take the formwork off and you just see the strata of earth, which is really interesting. Okay, that's a little bit about earth construction, but let's take a moment to shift our focus. You know, I've been talking a lot about embodied energy, but again, with climate change happening, we need to talk about carbon. So there's 2 terms that are really important to be working with linguistically, and that is operational carbon. So I talked about operational costs of a building earlier, but operational carbon is the emissions coming from the building during their use. So we're talking about heating and cooling and lighting and plug loads. These are all energy-based emissions. And this operational carbon accumulates year after year after year. So this will go into the lifetime of the building and its use. So it's important to understand and think about not just this initial phase, cradle to gate, but also what happens cradle to grave, you know, because the building still has impacts on our environment, on our energy grid on the inhabitants as long as that building is up. Okay, so that's operational carbon. Embodied carbon this is about the life cycle. That's the view, you know, from extraction to disposal. And so, but this is talking about the amount of CO2 and other greenhouse gases released into the atmosphere as a result of those first parts I was talking about, extraction and manufacturing of the building materials. And sometimes you'll even see, instead of like CO2, you know, if that were to be written, sometimes you'll see CO2e. And what that is carbon dioxide equivalents. Because when we're talking about not releasing carbon into the air or sequestering carbon, we're often not just talking about carbon dioxide. We're talking about other equivalents, you know, like methane, for example. I just want to just throw that into the mix so you can consider that in the languaging. Okay, so so that is one of the ways that the natural building community has changed its focus over the last 10 years, really taking a look at climate change and including that in the discussions, including embodied carbon and carbon storage and operational carbon and all of this, and, you know, and considering those impacts and how can we as natural builders be helping our environment, like what are some strategies that are going to help reduce carbon emissions? And it's, you know, it's pretty clear that this needs to happen. This was Sebastopol in the winter of 2019. This wasn't very far from where I live. I mean, people were kayaking through the gas station. And then later that year, we got evacuated. So I was down near where some of you might be in the Santa Cruz area. I was like taken off down to Carmel to avoid the fires when we were evacuated. And this summer up here in Sebastopol, Northern California, we started having our fires in August. So we were prepared to evacuate in August. We had all our stuff packed. My husband and I didn't unpack our boxes until last week after we got our first rain. So we're living in this really odd state, which is a hard way to live, but it, you know, it's our new normal until we can turn this ship around. So again, going back to the slideshow, like how can construction do its part in reversing climate change? That is what some of the dialogue is about currently. So there's lots of strategies, and if you really get into this and geek out, there's lots to be learned. We're barely touching the tip of anything in this presentation. But if I could, you know, reduce it into one line, build with plants, right? That would be one thing I would hope that you will take away. There are technologies and businesses, or rather businesses devoted to creating technology to sequester and harness carbon right now. And I think that's an important thing to be looking at, but you know, we have that technology that's called plants. Plants are the best carbon capture and storage system on the planet, and it's great because they do it naturally, right? And so if we take these plant materials and we use them in our building, we're going to take a huge amount of carbon out of the atmosphere now. And I say now in that way because there are some people who are really solely focusing on the energy efficiency of buildings as they operate over time. And that's great because that's going to help sometime in the long term, but we need to do something faster now. And this is one way to make a really big impact now without just having the benefits of things over time, because we really have to work fast if we want to reverse what's happening on the planet. Yeah, that's probably all I'll say about that. So let's take a look at some plants materials in terms of the built environment. Here I am a number of years ago climbing some really big bales. These are called 1-ton bales. I don't remember, I came across this stat, but it's great to see because we grow a lot of straw in the state of California, but in the planet already, there's 2 billion tons of grain straw that's grown annually. And there's as much carbon in the 2 billion tons of grain. Like if we were to grab all that grain that's grown worldwide and throw it and lock it into buildings, it would negate our worldwide transportation emissions for a year. So, I mean, obviously we can't, you know, everything isn't just going to stop and grab all the waste straw and throw it into buildings, but, you know, something to understand what we can move toward. So we really need to stop burning and then just letting our grains rot and waste, because that's how carbon is being released again. And instead we want to look at the ways we can capture it instead of having it break down or burn and then the re-releasing happening. So this is one way. And I love that straw bale construction is caught on. It's in the code system. There's a lot of straw bale buildings in the state of California and different parts of the United States now. And, you know, it became a building technique with the advent of the baler. When that was invented and used, you know, the first straw bale houses were done on built in the Nebraska plains. So they can look very different, again, like any of these buildings, you know, they could be roundish, they can be square, what have you. It really is about design. And then of course, understanding safe engineering. This is a house I worked on in Mendocino County. The lower portion is all straw bale and plastered with earth plaster on top of it. And then when you move inside, you can see the straw bale walls. If you look at that window, it's very deep back because you can see these really super thick walls. And they are all plastered with earth from, I think we got it from the site, if I recollect. And then we did natural paints made from clay. So again, this talk about how to harvest clay that I was going through last week, you can make your own paints. So that's what you're looking at here is a handmade clay paint on the walls. These thick wall systems are beautiful to be in. I don't know if any of you have had the luxury of or pleasure of being in a straw bale building, but it's really like, I've heard people say it's like being in a hug. One of the things I love about it is the incredible sound insulation. More importantly about, you know, relative to what I've been talking about here in this presentation is, you know, the heating and cooling of this building, the cost of that is hugely reduced over time because you have so much thermal resistance in those walls. You have lots and lots and lots of insulation, and that means heat or cold can't pass through very fast. When you go to the hardware store and you buy insulation, it's rated an R value. That's R for resistance, thermal resistance. So the R value of these walls are very high, way higher than code demands for wall system. So you're getting that plus the great sound insulation, and then there's the experience of it. And then you are just locking down lots of carbon that can stay in this for the lifetime of this building. And ideally that could be a long time. They also used waste wood for their flooring system here. And I think that's important to mention because again, it's a plant. It's was part of waste scraps because it was a type of wood where you couldn't do long planks. So they're like small squares. So they're picking a plant material, again, locking it in terms of carbon sequestration, but also using something, a type of wood that might not have normally been used. So they made a lot of really good healthy choices for all concerned in this building. The types of straw bale building, there's a few different kinds. This is called post and beam, and that is because we have posts holding up these beams, and that holds the weight of the roof. But there's one called Nebraska style where the roof sits straight on the bales. You would not be allowed to do that in many places, especially if you're in a seismic area. So the codes will let you know what is possible. Anyway, I just wanted you to really see what it looks like when you're stacking these bales inside a post and beam structure. You're stacking the bales up in between, you're tying them off to the structure so that they're not gonna separate out. We were filling the low spots with essentially cob, which is our mud mix that I explained before. You've got these metal strapping, that big X, that's for shear. What that does is make sure that the building cannot go at a square if there are any forces like big high winds or a semi truck drove into the end of it or something. It's going to stay square. So that's called, those are shear straps. And we've got a cement foundation there. This is in near Sedona. So the foundation isn't super high because again, we're in desert country. So what the codes demand for that might be different if you were building in Seattle, for example. And then we have some tricks along the way, but essentially we plaster over that. And this was just the local soil sifted through big screens and lots and lots and lots of chopped straw added to it. We didn't even use the aggregate in this case because we didn't need it. We were able to make a plaster and have it dry out fast enough in this climate. That's not all the case. You could not do this recipe in New York in the summer. Your plaster would mold because it would be so wet. So because this is desert, we could use a recipe that worked. So again, what is appropriate? What works in your bioregion? What are the materials you have on hand? And then this got a coat of lime plaster too, because again, they get monsoons in this area, so it'll get pretty rainy. This is another straw bale. Again, I just want to see you guys to be able to see the differences and what they can all look like. And this one's in Washington State, also built by the wild and charismatic figure named Sunray Kelly. Some of you may have heard. He did the, what was it called? The, not the chapel, the something at, oh my God, all the words just went. There's a big fancy building that burnt down at the hot springs up near Cobb, California. Oh, wow, forget it. If somebody can type this into the chat. Harbin, thank you. Harbin Hot Springs. His name is spelt like this, Sun Ray Kelly. And his buildings are super wild. So he did this big building at Harbin. It's really sad it burnt down, but his buildings are always spectacular and look like they're gonna fly away. So this is one of his creations. And if you wanna see some wild buildings, look him up. He's all over the internet. He's been on lots of TV programs and whatnot. And I got to work with them a lot in the early days. We would teach a lot of workshops together when I was in the, working with the Cobb Cottage Company. Okay, so here is another straw bale building. And so this one is even more interesting because it's a straw bale vault. So that ceiling is also straw bales. I will say, don't ever do this. This is in a desert climate. It was done by engineers and architects who have tested and know how to do this. And I can assure you that that plaster is not all natural on the top, because if water ever moved through that plaster and got into those bales, big heavy bales getting wet and dropping down on you will kill you. So they have definitely done something and would probably have to really keep up in their maintenance. So there's the warning about that, letting go of that. Isn't it beautiful? And this isn't 2 stories. This is a 1-story building. And it was made for a man named Lou Harrison, who is a musician, and he wanted an acoustically beautifully sounding building. That's why the vault shape was done. And because that vault is so high, you need these, you can see the 4 buttresses coming off to the left. And so those buttresses create 3 very nice courtyards on the north side of the building, but they also support the height of that building to keep it strong. And so that is an engineering technique for that building. And this is just outside of Joshua Tree. It's a artist retreat. I'm not sure if it's just writers or just all kinds of artists, but since Lou Harrison died, you can sometimes go to this building and do artist retreats. So this is the courtyards on the north side of the wall, which is where you want them in this case, because it's so darn hot there most of the year. You want to be in the shade. Now I want to move on away from straw bale, but still stick with the straw. This is another technique called light straw clay, sometimes known as slip straw. There's also a German name for it that I won't butcher. Because this technique does come from Germany, and really what it's about is taking a waste product, in this case straw, and mixing it into a usable infill material. So again, when I say infill, that means that there's posts and beams creating the structure and holding up the roof. Like you can have, like I showed you in the straw bale, but certainly there are straw bales and cob buildings where there aren't posts and beams, but the actual wall material is holding up the weight of the roof. But again, that's not allowed everywhere. Okay, so this building is built by a company named EcoNest. They are currently out of Ashland, Oregon, and they do these beautiful, really gorgeous light straw clay, healthy homes. They're very particular about the materials that go in and the process to create a non-toxic building. I had a resource list. I'll check with David, and these guys and some of the other references are on it. So just so you know, either you already have that, and if not, it will be coming to you. So what you're looking at here is, again, a straw wall system, but then a lower roof which protects the earth plasters on those walls all the way around. So that's a strategy. So if you know, you're like, I love the look of earth plaster, I want it, I have to have it, then you need to design for it. How are you going to protect that? And that's what they did in this case. This is taking you inside one of the EcoNests. So one of the beautiful features of a light straw clay building, and I will say in the traditional sense because there are adaptations, is that the structure of the building is timber framed. And what that means is we're using big posts and beams made out of wood. And in the traditional way of building it, they are notched together and put together with wooden pegs. So there are no metal parts in this. Again, if we're thinking about embodied carbon and reducing some of the costs of, you know, like certainly creating and melting down and hammering metals, this is a great alternative. And then the straw is pressed in between these posts and these beams, but you leave the posts and beams exposed because they're gorgeous. Another neat little strategy that they've used here is they have a couple of skylights. Instead, especially this house is in New Mexico, and they have a lot of sun days, as I said, you'd have a lot of very bright light coming down. So they sort of almost did like a Japanese shoji screen style, probably using some vellum or something, which really diffused the light in the space, which was a super nice effect. And again, all clay plasters, earth plasters there on the wall, non-toxic, non-off-gassing. So let me show you how this stuff is made. We take a straw bale, we pull it apart, we've made ourselves a nice working platform here, and then we take what is known as a clay slip, which is essentially just sticky clay and water made into a slurry, kind of like a thin milkshake. And this clay happens to be white, so it's a little bit hard to see. And then you toss your straw around in this mix. How much? Anything from like salad dressing on a salad when you're in a diet to when you're not. It doesn't have to be tons. It doesn't need to be super gloopy. And you mix that all up together. There's some kids we had working on site on a project in Mendocino County. And then here you can see these forms. They're called skip forms. And we have these forms on the inside and the outside of the building. And we fill up the bottom level of forms. And then when that's done, we add a next level and we fill that up. And then when that one's done, we take the ones up the bottom and skip over them and put them at the top of the wall. And as soon as the wall's all done, we pull the forms off and let it dry. So that's the building that I worked on. And that's what it looks like after we pulled all the forms off. Now this one isn't like that beautiful eco-nest building I showed you where you're gonna have all the wood exposed, the posts and beams. This was done more with 2x4s, and we just did a different wall system. So we're gonna cover all that up. We don't have that fancy timber frame thing going on here. But you can see these walls, and you can make them as thick as you want. So this one was 12 inches thick, and this is up in Ukiah, and they get, you know, triple digits in the summer. So this 10-inch wall system does really well. You know, when it's like 100 and something out there, it's 70s or inside this building without, I mean, there's no cooling systems in it whatsoever. So just keeping the heat out by having so much straw in the walls works really well. That's that same house after we plastered it. And we have a combination of earth plaster and lime plaster on this just because that's what the owner wanted to do. Nothing profound about it. She just had some particular ideas about how she wanted to handle it. So, but again, you know, the appropriate plaster for this building, and that is her house. Again, all code approved. The codes vary from county to county. So, you know, what you can do one place, maybe you might have a little harder time doing another. It depends where you are and what's allowed. This is the inside. We used her local soil from her land and just did all the plasters with this. And it was kind of fun because we had a whole female plastering crew on this one that I ran, which isn't always the case. So that was just kind of a fun little anecdote. And the woman whose house it is participated a lot and basically was the project manager for her building with the contractor she's hired. So that was neat. Let's talk hemp, everybody. This is important because over the years that I've been doing these presentations and being involved in natural building, this wasn't part of our conversation because it wasn't legal to grow here. So now that laws have changed and the Farm Bill is shifted so that we can actually grow hemp in the United States, it's a conversation. You know, certainly they've been allowed to do this in Canada for some time. So this is pretty exciting. Hempatexture is a company out of Idaho, and they're doing a lot of hemp stuff. They're fun to follow on Instagram if you're into this kind of stuff. And certainly there are some other companies that are getting into this, but these guys are doing a lot. They do a lot of workshops and what. So anyway, that's why I just put up their slide. Don't know them personally. But what is happening here is you're taking the stalks from the hemp plant and they're being ground up and they're very strong and woody. And this, very much like the light straw clay, gets bound into a binder, but it's not mud in this case. It happens to be lime, is what they're using. And again, it is squished in between forms, just like the light straw clay was. And I'll show you that shortly. But here's one of their job sites. So they've got these pallets of lime and then these bales of the hemp to the right of it, and then bins will they'll be making the lime and mixing all this together, probably in some kind of mechanized system. Oh, just a note, also with the light straw clay, people have devised machinery to mix the light straw clay. It's not like something you can commercially buy, but some ingenious people have developed their own. So again, in talking about scale, there's always low tech and then there's some sort of higher tech options for you to experiment with. Here you can see the forms and they're putting this hemp lime mixture in. Here's one of the interesting things about lime, and I think what's important about using it in these kind of contexts is that lime is very alkaline and therefore it's a natural mold inhibitor and fungus inhibitor. So they're great for bathrooms. You're going to be creating a wall system that isn't going to, you know, harbor these kinds of things over the life of the building, especially if you have any moisture in it. So that's important to note in terms of this mix. And they would press that in there and then take the forms off. And then, you know, it looks kind of similar to the light straw clay, even a bit similar to that rammed earth that I showed you, only because you're seeing these levels, these striations as you put it into the wall. And then you need this to set up, and I say set versus dry because lime goes through a chemical transformation for it to get hard, which is different from drying like the clay is doing in the light straw clay. And then you can plaster this. It's hard to see in the slide, but there's a coat of plaster on the left and none on the right. You can see the little individual bits of the hemp on the right. And you could put the lime plaster right on top of it. There's a wall that's gotten its base coat of plaster. There's probably something finer going on top. And this is a hemp house. Gosh, totally forgetting where this is. It's somewhere in the United States. I don't remember where it is. My bad. But again, like you would never know that this was built from plant materials. So that's one of the great things, you know, in terms of these materials. It doesn't, you might like hippie funk, but if you don't, your building doesn't have to sort of be all organic and round or whatever with the sunshine sculpted into the wall if that's not your thing. If it is, great, have at it. This company, I will tell you, they also sell hemp wool insulation, and that's a very new thing that we haven't had on the market, to get hemp bats. And their bats are, you know, perform similarly to fiberglass insulation, but certainly in many ways are outperform these toxic brands. So it's a great new option on the market, especially if you're, again, using plant materials, trying to bank carbon. Okay, so we won't talk about this too much, but you know, it is important to think about how you site your building. Passive solar, I mean, it's just free. It's just free heating and cooling if you work with the sun and the patterns of nature. So that's the goal here, to create structures that respond to the patterns of nature, the sun being the primary element. Let's take a look at an example. So here's a good example of, you know, a very modern passive solar house, a lot of glazing in the south side so that you can bank heat. It's essentially like creating a greenhouse, right? And you're orienting this, if you're in the northern hemisphere, this would be the south facing side of your building. And you would have this whole thing strung out in the east-west axis. This one here has some sort of berming on the back, which will be great because that'll help stabilize the temperature, because the ground temperature underneath will be much more stable. And so that will stabilize the temperature of the house as well. So, and you know, the overhangs, how far they reach out will be relative to your location in relation to how the sun moves through the solstices over time. Is it coming, you know, how high do your overhangs need to be if you need extra shading or you want less shading, that kind of thing. Those are calculations and modeling that you can figure out for your site, because it would be very site specific. Another great example of this is earthships. And although I don't personally consider earthships a natural building modality, they are in the natural building book. And so all that's to say is there are other people who do consider them natural building. I would consider them a little more green building because we're using tires that we're recycling. But I do want to talk about it because in terms of passive solar, this is a really great example, and some permaculture principles here. So this earthship is in the earthship community just north of Taos, New Mexico, and they have this huge area of desert where everybody who is part of the community lives in an earthship. It's all off grid. So again, you've got all that glazing in the south, you got your east-west orientation in terms of the axis of the building. And again, it's winter, it's 7,000 feet. I stayed in an earthship for some time up in that area. And you know, on days when it was snowing and we didn't have sun, and I was amazed. It was so warm. We didn't need to light a fire. you know, you got the passive solar that will heat when you have sun days, but you also have planned redundancy, right? You know, the permaculture principle. So you've got a wood stove, and you might even have another backup electrical heating source in case you ever needed to heat. But we didn't need to heat, and we could even open the windows to get fresh air in the day. And so one of the reasons of that, besides the glazing, oh, well, here's the tires, is the fact that on the back side, they're all earth bermed. Again, just like that last house that I showed you. So they're taking advantage of the stable temperature of the earth, you know, lower than the surface. So that really helps stabilize, and again, reducing heating and cooling costs over the life of the building. They have passive solar, but they also have active solar. They employ in earthships. Here's the tires rammed with earth. You ever want to get in shape, just make a cob building or ram some tires. You're going to be so strong. I used to have people stop me on the street all the time and ask me how I got my yoga arms, and I had no idea what they were talking about until one day I realized they were talking about manual labor arms from all the plastering and the carving and all of this kind of stuff that I was doing. Thank you for laughing, Shen Shen. And so it's a great way to stay fit. So here's taking you in one of those. Again, earth plasters on the walls. Really, they can be very beautiful. They process gray water. They have plants growing on side and the south side, as you can see here behind that glazing. You know, you can even see a banana tree starting to grow there. And again, this is like winter in northern New Mexico at 7,000 feet. So you can get away with a lot of things. So it really is a great design system. So you could, if you don't want to build with tires, you certainly could take some of these and steal them, incorporating them into any of these other different technologies in terms of the wall systems that I'm talking about. I will also tell you, for those of you who might be curious, that I never smelt tires. I would consider myself a little bit of a canary. Like if I'm in a house that has a lot of new paint, within a half an hour I can get a sore throat because of the off-gassing. I do notice that. I'm not chemically sensitive by any means. I would never refer to myself, but so, you know, just me being kind of normal, standard, a little bit sensitive. I never smelled tires or off-gassing in any of the earthships I've been. And I haven't been in a zillion, but I've been in a few. So that was my experience. Now, this is another great example of siting for your design. We're still dealing with the concept of passive solar here. This is what is now referred to as ancestral Puebloan dwellings. And this is in Southern California. This is Mesa Verde. And this dates back 1100 to 1300 AD. So, you know, people have understood the concept of building and working with the sun and your elements in your bioregion for a very long time. This is really evident here. This is in July, so it's very hot. And they made sure that they built this dwelling underneath the overhang of this cliff. And because the sun is high in the sky, you can see that it's shaded in there, so they're not getting overheated. Now, if we were to be there today, certainly that sun would be much lower and it would be hitting those walls of those stone dwellings, and that would be heating up that mass. And it's important because mass is the opposite of insulation. Insulation is light and fluffy and makes you warm, like your down quilt or your down jacket or your straw wall, right? Mass is like stones, heavy things. You sit on a stone in the winter, if there's been no sun on it, it's very cold. It's like, you know, it's like an icicle. And same would be with these stone buildings. So it's important. They would have to have sun on them in the winter to heat them, or at least a fire to be heating that mass up. So you really do want to understand the difference between insulation and mass in buildings. Cob is mass. All these straw stuff is more insulative, and they're all on a sort of a spectrum, of course, and especially if you're mixing them together. Also, there's plaster. If you go visit this place, you can still see plaster. And I tried to see if my laser pointer would work on a computer, but it didn't. But that highest tower there has a little white area, and that's some of the original mud plaster. So talk about siting your building, right? Like that overhang has protected that mud plaster since whatever 1100 or 1300 AD, somewhere in there. And that's just like, that's mind boggling. So again, if you as a permaculturist are observing your landscape, watching the cycles, watching the wind, all the kind of things that they're teaching you in these classes, and then you take all that knowledge and put it into your building, I mean, you can have a building that lasts a very long time and performs really well. Now I just want to show you some other just kind of fun eye candy of natural materials. These are the traditional fireplaces that you will see in the Southwest, all built from bricks, plastered in mud, beautiful heat source, kind of a fun thing to get to encounter or even make. Ooh, here we're going back to Europe and looking at some of their works. Again, I apologize, I don't know who the builders are in this stuff. But also what the Europeans are very famous for doing is building these ovens. They're called cockle ovens, some of them. And I don't know that this one is, it might be one, it's hard to tell, but they have a very small firebox, and then there's a series of baffles that will go through all that, in this case, cob, but essentially it's mass, right? It's heavy material, mud, right? And it will heat up that mass. So what happens is that over the course of the day, it will radiate out. And so you can use way less wood by taking use of that mass and having a little fire in it every day, for example. And this is just crazy beautiful too. People have been working with other materials like stone forever and ever. Here is a beautiful Peruvian woman who's knitting in front of some stonework down there, and there's an 11-sided stone on the right. Nobody knows how they did this, but it's, again, mind-boggling. So yeah, look to your ancestors to see what kind of beautiful and miraculous things they did with the built environment. These are stone houses in London and somewhere in that area in England. Again, you can see the thatch roof and get a really good shot of the profile of how thick it is. And they're rebuilding this stone fence. So natural materials come in all forms. Again, here, just to note, this would be mass again. So, you know, if you're in a forest without any sun, you don't really want to build a mass building unless for some reason you have so much wood, you can have a fire in it every day so that mass never cools down. So you want to think about what is appropriate and what is the goal and what's the function of the building contextually. These are the roofs of buildings in Italy called trullis, and they're really kind of fun. I think you can stay in them these days if you were allowed to go to Italy. But initially when they were built partially as a form of tax evasion. So the people would inhabit these trullis, but then when the tax collector would come, there'd be a runner coming through the village going, the tax collector's coming, the tax collector's coming. And so they would grab the stones and then pull off the stones and dump them in a pile in the back, and then they would move their meager belongings out and put the, you know, the goat and the sheep in, and they couldn't get taxed on their agricultural building. And then the tax collector would move on and they'd stack the stones back up and move the animals out and move back in. So just kind of a fun little bit of lore about these buildings called trullis, T-R-U-L-L-I. This was at David's old place. This was his bamboo forest, as I like to call it. And bamboo's another great material, another great plant material, especially in terms of storing carbon. It grows fast, so the plant is doing a great job. And then if we could harvest it and store it, it's great, great option. beautiful as it grows in its natural settings. Here's an example of a building by an architect named Simon Velez, who works a lot with bamboo. And if you're into bamboo and do not know his work, you should look him up. He's a Colombian architect, and he has a book called Grow Your Own House. And he's done buildings all over the world, really spectacular pieces of architecture. And you know, you can do all sorts of things with it. You can make a truck bed. You don't need to have bamboo, but if you do have some other plant material like this guy in Africa, you could be weaving your own body of your own car. And you can go on YouTube and see this thing run. That's the other kind of fun thing about it. So if you're into it, check it out. Here's another building somewhere in Europe that's mostly roof. So those walls are certainly protected. Again, made from some kind of thatch material. Now, because a lot of wetlands are protected because we're running out of them, they're using other grains for some of these kind of roofs. So it's not always the phragmites that I told you about. Here is an earth building. This is the mosque in Jenne, Africa. And every year they have an event called Crépissage, where the town kind of splits in half and has a contest of who can finish their side of plastering the mosque. You can see their OSHA approved ladders, and then some of them are just on some of the wooden spires that they also use as scaffolding to apply the plaster. But again, going back to the traditional upkeep of buildings that happens, especially with earth construction all over the world. These are earth high rises in South Yemen. I do recall this is one of the pictures I am not allowed to share, FYI. And so a lot of these are fired brick, some unfired brick, and covered in a white plaster because it's hot. And so that white plaster will reflect the heat. And so I think the tallest one is 13 stories. So again, it's not a seismic area, this place, but this is what they have. So they've made best use of based on what materials are available to them. This is a building from Cal Earth, which is in Hesperia, California, and they train and build examples of something called super adobe, which you can take a look. But this is a kind of a fun plaster that they decided to do where they balled up the plaster and placed it on the walls. This happens in Africa too. They throw it and it bonds with the in that case, mud walls underneath. Here's another traditional dwelling. This is a hogan, which is in the Navajo Nation in Arizona or New Mexico. I don't remember which part of the Navajo Nation this is on. But, you know, again, desert climate, they used a lot of wood that they would fill in the gaps with mud and then pile a lot of mud on the roof because it gets so hot. So they're trying to insulate. And this is their traditional building style. And when you go inside, you can see all the wood. They don't always have that amount of wood anymore, so there are more modern versions of this done, but this was a more traditional version if they had access to a lot of trees. So it kind of looks like an aperture when you're inside looking at the ceiling almost. You can make a mud pool table, especially if you got some good reeds to create a structure and you can mud over and you got a few limes to use as pool balls. So, you know, the saying, necessity is the mother of invention. I love that these kids did this. It's really, truly amazing in Africa somewhere, using their local materials. And if you live in the North Pole, maybe these are your local materials. Another natural building material, water turned into ice. Here we have a pool table. There are people who make ice instruments and play them in the winter. You can go to concerts. You can go to Sweden and stay in the Ice Hotel, which is an ephemeral hotel. They have a non-ephemeral one as well. I mean, human ingenuity is incredible. And then, of course, there is the famed igloo. And you know, and this is an incredible design to stay warm in a building of ice, and the geometries are such that when you enter in through, you know, sort of a tunnel that's lower, but the place where you sleep is up higher. So of course heat rises, and if they have a little oil lamp in there, their bodies are up near the top of the igloo where it's warmer. And you know, really, really interesting geometries and way of building this that people would need to learn how to do to survive. And this is my last slide. And I think what's important about this is that I know for myself is that when I look back on my life and, you know, look at all the things I've built, that I want to be able to feel good and know that I left the world better, you know, with my efforts and the consciousness and with how I built, and, you know, and that would be my wish for all of us, that, you know, we could leave this planet better than when we found it. And so, again, I think the main thing I want you to really think about is that the fact that we as builders, any of us who make a choice to build, can make an impact, especially now in terms of climate change, specifically if we're at the very least looking at some of our material choices. And that can be huge. It's not a little thing. And to just give you an indication, I mean, they're all sort of fancy buildings, the passive house, the net zero house. There's all these strategies in terms of creating carbon neutral building. But if you just built a regular house and tried to make good choices about its energy efficiency and performance, and then simply swapped out your materials, so you were using, you know, wood siding, wood flooring, particle boards, you know, that are using wood waste, whatever kind of plant stuff. If you just did that, forget even making a natural building, you would create you could easily create a net zero building in terms of carbon emissions. So if you're creating one of these buildings that I've been showing you, one of these straw bale buildings, or, you know, light structural buildings or hempcrete buildings or any of those kind of buildings, not only are you're getting more than a net zero building in terms of carbon capture, you're actually going in the other direction on the graph, where you are your building is going to be net zero for the next 100 years because you've sequestered so much carbon. So if everybody started doing something like that, we would capture huge amounts of carbon. So I just really hope that you get the impact of those kind of material choices for the heating of our planet, but also for the well-being of occupants, you know, choosing less toxic materials. So we don't have to spend our part of our life dealing with things like cancer or whatever kind of toxic diseases we might get because we're just too bombarded by things that aren't healthy for us. So I hope that you can take away some of that. I'm going to stop the sharing now, and I'm going to open things up for questions because I wanted to make sure we had time for that. And I know I answered some of them along the way, but maybe some of you guys have some questions that you want to ask me, and I am here at your service.
Janine, quick question. What's the economic impact of this? Is it any cheaper, the same price to build an eco-natural house? Could you just say a little bit about that?
I totally can. You're not going to like my answer though. It's really one of these depends, because it kind of depends on how you do it. You know, you can certainly build a very cheap natural building, and there's lots of examples of people doing it, especially if, in all honesty, if they're they're renegades and they're not going through the permitting process and they're out in the back 40, so to speak, and they're using a lot of their own labor and recycled materials, and you could do it, you know, dirt cheap, pardon the pun. But then when we're inserting these kind of things into the current code structure, then of course permitting and all that stuff is going to drive costs up. But let me give you an idea. Some of these houses, like straw bale houses in New Mexico, I had friends who were building them for $150 a square foot. Those fancy high-end eco nests, they're probably more like $300 a square foot. So again, like, what kind of house are you building? How fancy is it? And you know, are you using communities to stack your straw bale on a, you know, on a day? So there's never really been a proper comparison done. And especially because one of the things is, and we always talk about this in the natural building community, is that if you really wanted to compare, let's imagine the conventional house. We build 1,000 square foot conventional house, you know, stick frame construction, you go buy all your materials. And even if you use stick frame construction, let's say this one's light straw clay over here, but it's going to be natural. How do you calculate that? Because some of these natural people are going and felling their own wood. Do you include that in the hourly calculation? So there's never really been a good study. So that said, it will depend on where you are. It will depend on permitting fees. It will depend on, you know, how fancy you want your house or not. But certainly it can be cheaper. And I will tell you one thing that I've seen over the decades I've been in this movement, is that people are interested. They want to come and help you build your house for free. And that is not what's going to happen on a conventional stick frame house, generally speaking. So you get, you know, maybe you don't want that, but if you are looking for help from the community, it's available. And that's really great. So there are sections of the building where you can just save a whole lot of money and have a really fun time and a great pizza party later, you know? So hopefully that somehow addresses your query.
That's great. Thank you.
Yeah, you're welcome. Anybody else have a question? Yeah.
Can I know a little bit more about your background? Are you an architect? Did you study architecture?
Yes, none of the above. Okay. I was living in Vancouver, BC, and I was actually going into the movie business, quite honestly. That's where I was having my training and was working, and decided to go take a workshop and build an earth oven. And it turned my life upside down, really, because I ran into somebody one morning walking to the bakery, kind of a stranger, and they said this one thing to me. They said, if you were going to die tomorrow, what one thing would you regret having not done? And I heard myself say, give something back to the earth. And then I just went, oh no, the movie business is kind of toxic. So I just like left and went straight into natural building. So I ended up doing an apprenticeship with a company called Cobb Cottage, because that was the people I did the workshop with. So I took another workshop, and those particular people were actually very happy that I was not an architect and didn't, you know, or an engineer. Well, maybe an engineer they might have been a little bit happy with, but but in terms of like a designer or an architect, because what they were doing at the time and really their methodology of teaching was really outside of the box and in some ways kind of revolutionary. And so their experience with somebody who might have been an architect was that I would have had to unlearn so much stuff for them to be able to insert their information. And so in that regard, they were actually happy and very welcoming that I didn't have that, because I was just like an open sponge with no preconceived notions. I will say that, you know, I'd been good with my hands. My dad was in the, you know, was a construction person who had his own company. So, you know, I was kind of in that world, so it didn't feel completely foreign to me. And then when I was starting this in the 90s, there weren't really any places to study this. There was one program to build a straw bale house in Canada that I was looking at taking, and then they canceled it. And so I couldn't actually like they weren't eco-dwelling programs back then. And so ironically, I ended up teaching as faculty as part of an eco-dwelling program down here in California when I didn't have the degree because there was nowhere for me to get one prior to that. So it's different now. And now you could go to school and learn about these things, and it could be much more official. As when I started, they didn't have those avenues in the same way as they do now. Maybe that's more than you wanted me to say, sorry.
And so how do you find these jobs when you're working on buildings? How did you get involved that way?
Well, I spent a few years with Cobb Cottage, and part of the natural building community, particularly at that time, is there wasn't many people in it. So kind of everybody knew everybody across the country, and we would have a yearly gathering where everybody would come together at a colloquium. So you made connections and you networked really well that way. And then we all supported each other in creating, sharing jobs. It was very much community sharing based values, which is one of the things I loved. So it wasn't built on competition and just me and harvest my own resources. It was more like, how can we grow all of each other up? So I would say, especially in the early years, it was much more easier to sort of get jobs. For myself, really, I really haven't done a lot of advertising, and I'm not rich or anything, but I've definitely made a living. And I think the quality of your work will show as well, and that's part of your calling card. But there are organizations and people who specialize in each technique. So there are certainly people to reach out to if you want to get involved. If you're like, I love straw bale, or I love whatever the one technique is, that I or somebody else could direct you to in terms of how you get involved and start meeting people and getting in jobs. And I would say one of the obvious ways to get involved too is go help out on somebody's building for free. And then, at some point you can start getting paid. So, and if you are a carpenter already, that's a great trade resource as well. When I started learning, I had the natural building skills, but I didn't have the carpentry skills. So I made a trade with somebody to, I would teach him all the natural building stuff I knew, and he would teach me carpentry because you need to know that. And so at some point I learned enough where I started teaching wood shop for women, which is a course I taught for 10 years as well. And so, again, a lot of skill sharing. Do I live in a natural home? I do not. I live in, the cobbler's children have no shoes. It's one of those things. I live in a conventional home, but I have naturalized my home. So everywhere I've moved, I have put clay and plasters up on the wall and transformed it. This yellow wall here is all handmade clay paints that I've put up on the wall. So for me, what method would I choose? I would probably make a light straw clay home, maybe even hempcrete. I've never actually done that, but something like that. And that's really part of it's personal, because I want to do something I'm interested in, feels fun to do if I'm going to be building it. And, I made so many cob batches, like I don't have to see another batch of cob for as long as I live. And that's just my personality type. I kind of feel done and complete, and then I move on to the next thing. And now I'm also in a phase of my life where I'm really liking the straight lines and the modern elements, but also combined with natural materials and textures. So that's just an aesthetic I'm into. So, and it would perform very well in the Bay Area, especially, with how hot it's getting in the summers. And again, with my mission and my values around natural building, I would want to be doing something in terms of responding to climate change. So I again would probably pick a plant source material, because that really feels good to me. So for all those reasons, I think I would choose one of those. No, our coastal fog does not affect cob's strength whatsoever. I mean, once it dries and gets plastered, it's just super hard. You could even, like rain, or if you took a hose to it, it's gonna wet it, but it's not gonna dissolve unless you just built a wall out of silt or something. I mean, if you think about the ground, and most of our ground just doesn't erode when it gets wet in the rain, it's stable to a certain degree. Certainly there are slides and stuff here and there. But when I was working with Cobb Cottage and I was living up in Oregon where they get a lot of rain, we built a little cob wall with, you know, we didn't roof it or anything. And we just let it get hammered with rain and it wasn't plastered. And I mean, it eroded so slowly, you know, over the 2.5 years I was there, you barely saw any erosion. So it does take some time. Now, if you had a pipe going through your cob wall that broke, so you don't have pipe connections in your earth wall, that's just something you learn, and that broke and it soaked it, yes, you would have a dissolved area and could result in wall failure. But fog is going to do nothing. And even rain will move into your wall system, then just dry right back out. Again, provided you didn't plaster it with something where the moisture can't get out. Organizations, apprenticeships, jobs, trainings to get started in the field. Yes. And that's on the resource list that I will again check with David, see whether it's posted somewhere or it will be sent to you in email. So I've got, you know, like one for Strawbell, you know, one for Cobb, an apprenticeship that I think is good right now. Obviously things are different because of COVID, but yeah, you'll get some of that. Did I miss something? Let's see. How could I get more experience? Yeah, I interested that. I'm also interested in applying the techniques in an art context. Well, okay, so if you want to apply the techniques in an art context, Shenshen, one of the things on the resource list is the Canelo Project, and they specialize in straw bale construction in Southern Arizona, but they also do this fantastic class called The Art of Clay and Lime. And you can learn all about plasters. And that's really like when you're getting to the art, you want to understand the paints and the bas relief and how to carve and all of that. And you get to spend a lot of time learning and doing those things in the field at their course. And it's really rich and there's a lot there. So that's the Canelo Project. I'll type this in. The Art of Clay and Lime. Oops. So that's what I would recommend. Yeah, okay. Any other questions? I appreciate you guys being so interactive because, you know, the Zoom world is so different. And normally I have you guys right in front of me and I can ask you questions. And so I've had to like cut back on all my questions and just talk at you, which is not my preferred method. I like to interact and evoke. And so it's really nice to have you guys type stuff in the chat and be able to answer your questions. So thank you very much for being so present and participatory. I appreciate it a lot. Are we there? Are we complete? We got a clap from Amy. All right. Well, okay. So it's hard to teach on Zoom. Yeah, thanks. I'm glad you're thinking it's awesome. I'm glad you're getting stuff out of it. Here's David to help close us off. Hi, David. What should we do with our clay? Well, nothing yet. If you've got it all processed and sifted, just bring it Sunday morning, and that's when I will tell you what to do with your clay in the nicest way. And so make sure you consult the list of stuff to bring, figure out where you're going to be, because, you know, if you can be outside and still have internet connection, great. But if you can't, you got to find a tarp to bring inside, that kind of thing. Yeah. All right. David, do you want to say anything to close?
Sometimes when I have nothing to say, I think of this phrase. There's, what is it? What else to say? We end in joy.
Yes. I have one thing to say, though, joyfully.
Definitely.
David, did you post that resource list from last time, or should I send it again so everybody has it?
Ooh, I think I did. Are people saying they didn't get it?
Well, no, they're asking me for resources, and I said I have a list. I don't know if it's posted somewhere, or I should send it again.
The one you sent last week.
No, I sent you a whole list in May, and I didn't know whether Should I send it again? It's easy. Should I
If
send it
you
again?
can.
Yeah, no problem.
It's probably not hard for me to dig it up either, but it would be easier if you
Yeah,
sent
okay, I'll send it again. So team, you will get that somehow, either in an email or it goes into a resource area. I'm not sure. David will tell you.
both. We'll do both.
Great. All right, thank you, my friends. So nice to spend Monday night with you. You still have time to go eat dinner if you haven't done it. Mwah.
Mwah. Thank you.
Thank you.
Thank you.
Okay, you're
Thank you.
welcome.
Nice to meet with you.
Welcome, everybody. Good night.
Good
Night.
night.
Nice to
Bye.
meet you.